Hi everyone. Today we are continuing building the Snake JavaFX FXGL Raspberry Pi game with Frank. Hi Frank.
Hello, welcome again.
So do you want to tell us what we're doing?
So let's show where we finished last time. So we had this very small snake game. We could grow the snake with a foot, F button, and you have the arrow keys to control the game. So very simple game with a lot of history. Wasn't this one of the very first games that was created? Now let's take the same game and move to the Raspberry Pi and make it more interactive with some physical stuff. So I want to show you a few things. Yep. So I have here prepared for today.
Nice.
I have this arcade-like controller. Now it looks pretty heavy, but it's actually a very easy, simple thing. It's just, you see the four red things here that are actually touch buttons. So by moving the joystick, you click one of these buttons. I have this one. Then I have a bunch of other buttons. Actually, I'm only using one, the pink one, for today.
Yeah. Well, there aren't many controls in Snake game
Voilà,
at the moment, so yeah.
It's only to give the snake food, which should actually be one thing in the game that we still need to extend.
Yeah.
And then I have a Raspberry Pi, and on top of this Raspberry Pi, you have the Pi-Gate head. It's not really obliged to have this, but it makes it easier to connect all these connections to the right place. So the joystick is connected to one, and here are the buttons.
And are these publicly available? Can we buy those?
Yeah. So if I go to, I have here the website. I buy everything for Belgium. I buy it from in Netherlands, Kiwi Electronics, but you find them in many different. On eBay, you will definitely also find them. So this is the button kit. So you have a lot of buttons. Actually, you have 10, and you have this joystick, and then some of these wires to connect everything to a Raspberry Pi.
Mm-hmm.
And this is the Pi-Gate hat. There are two versions. I think this is the second one, because you also have this USB-C connection and a power button for the Raspberry Pi, which you actually don't have on the Pi itself.
Right.
And there is also connection for the sound and for other electronics. So the idea is I will have some students from a Swiss university working on this project to create documentation for the Pi4J project. And that's the next thing I want to show you. What is Pi4J? It's a library created for the Raspberry Pi to make it easier for Java developers to work with electronics. So how do you use a Raspberry Pi in this case? You have all these little pins on a Raspberry Pi board, and that's where you can connect electronics. Like buttons, like LED lights, but also more complicated stuff like screens or LCD screens, or a lot of sensors. But now we are using the very basics of electronics, being an input button, an input which you close the connection for a short time. And why the Raspberry Pi? Well, it's very cheap. That's one thing. And on the other hand, on the other side, you have these pins, which is very difficult to connect any kind of electronics to a normal PC. Becomes very easy with a Raspberry Pi.
Yeah, so now, essentially with Pi-Gate you have something like a controller, like a DIY controller.
Yeah. It's something you can build yourself, and you can attach as many buttons as you want or you want to use in your project. So it's a very low-level entry point into electronic programming. And together with this Pi4J library, it becomes even easier. So you don't need to know a lot of electronics. It's the library taking care for this. Now, if you look into this 40 pins that you have on the Raspberry Pi, So these are a visualization of these 40 pins. And here you see a lot of numbers. So this is where this hat, which is stacked on top of the Raspberry Pi, is connecting the wires of every input. So for instance, for the joystick, so you have here the right, you have the left, you have the
so you
up, the
can
down.
also read the
Yeah.
button numbers as
Yeah.
well.
So each direction of the joystick is a different pin. So the down pin is number 6, the up pin is number 12. So the GPIO numbers, that's where you need to look at. So that's what we're going to use in our code. Okay. Now, what you see now is a screen sharing I'm doing from my Raspberry Pi. So I'm programming on the Raspberry Pi. It's the Pi 4 that I'm using with 2 gigabytes of memory. So it's a device of, I think, 45 euros, something like that. I have installed Raspberry Pi OS, the full edition, which comes with a lot of programming tools.
Is this
Normally,
Raspbian OS or?
it was Raspbian. So Raspbian was an open source project, or is still an open source project, and the Raspberry Pi Foundation used it to build their operating system.
Okay.
But they moved away because they had a lot of other versions that they wanted to build. So they made it a bit bigger and more complex. And that's why they rebranded it. So it's some kind of fork of Raspbian,
Right.
but it's now officially Raspberry Pi OS.
Nice. Okay, and you can download it for free and install it, right?
Yeah, and they even have an imager tool on the Raspberry Pi website, which makes it very easy. You just
Right.
pop in an SD card and you select which operating
Yeah, I'm
system.
going to need all those links from you later on, so I can put them in the video description.
By the way, Pi4J has a new website, this one, which was just released this month. And to get started, you have all this info here as different pages. So, for instance, how to set up a Raspberry Pi, how to install Visual Studio Code, and then this project, which we will now be working on, is also one of them, game development. So the idea is that the whole description of this project will end up here. But as you can see, it is to do.
That's fine. Yeah, we can make it happen.
Yeah, voila. Now, let's go back to the sources of our project as we finished it last time. I made a few small modifications. Actually, the changes needed to integrate this joystick was very simple. We have here the Pi4J version that we added. We are using version 2 of this library, which is work in progress. There is no final version yet of this. There is no released version.
Right.
So that's why we also add the repository link here in the POM file with the snapshots enabled. And then you have a few dependencies to Pi4J. That's one thing we added here in the POM file. Now, if we go into the main class, where we have all the logic to start the game, there is one new variable. I also called it the Pi4J factory to be in sync with the FXGL factory. This is initializing all the Pi4J stuff, all the connection with the GPIOs, which is actually very small because of a few smart things that you have done in FXGL. So let's take a look at what is here inside this code. First, some definition of the pin numbers that we are going to use.
Okay, nice.
So you see this pin joystick up number 12. Now, if we go back to this,
and these map to the numbers that we saw earlier.
Yeah. So you have this here. GPIO 12 is the up direction of the joystick. So that matches one-on-one with here these numbers. And I only use one button, my ping button, which is connected to GPIO 5.
Okay. Yep.
Okay. There is inside the library SL logging is used, but you have this console, which is a helper provided by Pi4J for logging. And then you have the context, and the context is the Py4J, that it knows on which board it's running, which providers it needs to use, but that's all internal stuff. You don't really need to care about it, because you can say, give me an automatic context, which will just check which Raspberry Pi is this, which type, and then give you the correct dependencies. And then we have here an init where we define all our GPIOs. So GPIO stands for General Purpose Input Output. That means that this pin can be used for any kind of usage, being an input as an output pin. Now, for us, these are all inputs. So we have a joystick up, down, left, right, and then the button for giving the snake some food, that it grows. We link it to these pin numbers.
These are the numbers,
we defined before, and then
we map back to JavaFX.
We are using the key codes that we already are using inside our application. And the thing is, if you would build this Raspberry Pi into some kind of housing with only the joystick and no keyboard, we can still use these keyboard codes, because it's very easy to test in that case. But if you don't add a keyboard to this Raspberry Pi, then the joystick becomes the only available option to control the game. And now this is the function which is really creating this input. So it creates a digital input within Py4J. It gives it a unique ID. Then the address is again this pin number that we defined before. Pull up or pull down is a system to define on which event we need to trigger if the button is pressed or released. We have a debounce to make sure that this is one of the strange things when you come into contact with electronics. It's not a 1 or a 0. It can toggle very fast. For instance, if you press a button, you have some electronic events happening, because the contacts of this switch become very close to each other, and then you have some toggling between it's true or it's false. So this debounce will make sure that this doesn't happen. And then the provider is a fixed value that we need to use. And then we have a listener. So because it's an input pin, we can add a listener, and this listener will fire whenever that is input state changes. So if it's low, that means that the button is pressed. Then and this is the fun thing about the FXGL, that you have this mock key press. Then we say it's actually pressing on the up arrow, or it's the F button. And if we release this button, then we also release this key. And actually, this is the only thing which was added to what we already had the last time that we were working on this little game.
Brilliant.
Is this whole thing. Now, there are a few issues I'm still having with Visual Studio Code on the Raspberry Pi, because there is the nice thing that if you install in Visual Studio Code the Java extension pack, then it adds a lot of Java stuff to Visual Studio Code. And you see, for instance, this main, it recognizes that it is a runnable thing. So you can click run, and it will try to start this application. And then I end up with something very strange, and I think it has to do with JavaFX. The application actually starts, and that's it.
I can see lots of errors coming from JavaFX in there.
Stuff going on there. Now, what is the good thing, and I really have to stop it with Control C, I guess. Voilà. Now, the good thing about JavaFX is that we have runtime provided by Gluon, which is designed or built for the Raspberry Pi. So it is described here. It involves a few steps. So you need to go to the Gluon website and get the JavaFX dependency there, and then put it on your Raspberry Pi. It's only 3 commands, and you need to provide the location of JavaFX inside the start commands of your application. Now, I tried to do this with the launch settings, and I think I need some assistance of someone who has more experience with Visual Studio Code. You have this launch settings. Where are they? You can provide all these here, but I wasn't successful yet, so I'm not going to do that. Luckily, we have a Maven project, so let's package it. And it's amazing to think that we are now working on a 45 euro PC with an IDE. We have the full Java GDK, OpenGDK 11 here. We have JavaFX. We have, everything is here to build full applications on this very cheap device. And of course, because this is a demo, it seems to have crashed.
That's all right. I suppose the Raspberry Pi devices are going to get faster and faster as technology improves.
They released this Raspberry Pi 4, I think a few years ago. They started with 1, 2, and 4 gigabytes of memory. Because there wasn't an 8 gigabyte yet at that time, a memory chip. So that changed. So they stopped with 1 gigabyte and they shift the prices. So now you have the 2 gigabyte at the price of the initial one, and you have a 4 gigabyte version and an 8 gigabyte version. Yeah, this is indeed longer than expected. Can we close it? Why does this always happen when doing a demo?
That's the nature of demos.
Otherwise, it isn't a demo, indeed.
Yeah, exactly.
So let's try it.
Pre-recorded video.
Okay, we're back.
And I assume this can be done just from Bash without the IDE.
Yeah, of course. Yeah. And also, you can create everything on your PC, make the jar file, copy the jar file to your Raspberry Pi and run it there.
Right.
The only thing that you cannot test on your PC is this whole Py4j stuff.
Yeah.
Because you don't have these connections there.
I wonder if there is a way to add a bridge of sorts over the network, for example.
Yeah, that also exists. So actually, Py4j, the library, is not doing the actual GPIO stuff. There is via GNI. It is using a C++ library, Py GPIO. And actually, this thing has a daemon that you can interact with it through TCP. So you have some kind of client-server communication. Of course, you have then a small delay. Because you're
that's fine, because we're working basically on a different machine.
It becomes more an issue if you're doing real machine control, for instance.
Yeah.
So, okay. So we run the Maven command, and this time it didn't crash. Now, I moved to this target distribution directory. So this was created by Maven. And this is the one we need, the run file. So the Py4j version 2 uses the modular approach. So it creates all different jar files, and this run command will make sure that we have everything in place to control our game. So let's see. So we have the joystick here. Wait a bit. So now you can see that with the joystick, I can control up. and I have up, and that's one we have to investigate. There is somewhere a previous position does not exist. That's one we will investigate in a moment. Let's try it again. I've written down where the error happens so we can take a look at it in a moment.
Yep.
I had it before.
What are the loading errors? Are these some native calls?
There are some native calls and some fonts stuff, but I think it's more inside JavaFX itself. So you see I have this button to make the snake longer.
Yep.
So actually it's just doing the same thing as with the buttons. So this is the F button and the joysticks are the arrows.
Up, down, left, right.
Yeah. And now you see we don't have this error we had before. Well, okay. Where is my mouse? And stop it. So here are all these console logs that I was showing.
So does the console just literally reroute all messages to system.out?
Yeah, indeed.
Because there is a built-in logger in FXGL which we might use.
Which we could also use, yeah, indeed.
In which case there is no need to have an extra object.
Yeah, then we can indeed remove this one.
Yeah.
This console. Yeah. So this login that you see comes from this button event.
Okay.
Input event.
Are there just two states, low and high?
Yeah, indeed. It's digital, huh? So it's a digital state. It's just a 0 or a 1, meaning on the Raspberry Pi, if you connect something to it, or if you connect a LED light to light up, it's 3V 3. So that's the one.
Okay.
If people are using Arduino, which is then a microcontroller and doing electronic stuff, most Arduinos are on 5V. So in projects where you would try to mix them, you have to be careful that you don't give this 5V to the Raspberry Pi. It only expects 3.3. The error we were having was here on line 95. So it's in our work of last time. So it's not related to the electronic stuff. Although I think it's because this button is maybe faster than the F button on the keyboard. I don't know. But it gives an error
input
here.
handling should be single-threaded. So it should be fine, even if it's too fast.
Yeah. It's on this previous position, so it doesn't find this. So here is where the error happens.
Okay, so the last body part comes from the body parts list.
Yeah.
And where is that updated?
I think we created or we updated.
Well, actually, that's where it is updated, right? That's the only place where it's updated, isn't it?
And what do we do in the move? Here in the move. What do we do here? Previous part is getting.
Let's have a look at the grow method. And this is the only the last line at line 99. I think that's the only place where we add a new body part.
Indeed.
And at that point, after we've added it, it doesn't have previous position. So yeah, yes, you're right. I think it is too fast, but not because of the single-threaded issue. It's because when we mock something, it will respond immediately. So if you're mocking it again, I think it will be calling this method again. So what we need to do is just, after we've created the body, set its previous position property, and then everything inside body parts should have a previous position. Yeah, right there.
Oops.
It's odd
It says,
not to see it reasonably quickly because I'm so used to IntelliJ.
yeah,
It's set
that's
property.
indeed, yeah, it's not that fast.
Yeah, but that's fine. I
So,
mean, it's cool
and
anyway.
I have to try it out, but we have here, someone set up an example, a Maven archetype, to develop on the PC and build your project and automatically deploy it to the Raspberry Pi. So I think this is a very nice way of working, that you really have the full power of your PC to develop. And as soon as you build your
and you can
project,
deploy
then
it.
it's automatically through SSH pushed to your Raspberry Pi, where you can test it and run it. So that's a very nice approach if you have the two side by side. But yeah, you see, you can program here, but yeah, it's not that fast and it's not that responsive. I only have it. This is a 2 gigabyte memory version, so it's the smallest one. Because I needed a few new ones and they were all out of stock. So they are so popular that I think you need to wait 2 months for the 4 and the 8 gigabyte version. So these were the only ones I could get at this moment. Okay, what should we set here?
I guess the position, yeah.
Just position, yeah. Do I have to make it an...
No, I think that's it, pretty much.
It's recognized, yeah. It takes some time before it's recognized. So this is probably then the error we had. Okay.
Now the hardest part is to actually see if the error is still there. But
yeah, I just played then with... my son wants to play it tonight. He said he didn't see it yet with the joystick, and
right.
So I told him this morning that it's almost working, and so he wants to try that. So he will be our test.
Yep, QA.
Test
Quality
engineer.
assurance.
There is one major issue that our game has no game over. If our levels
no win
are
or
below
lose
0,
condition, as we say it in game dev.
Yeah, you can just continue. So where did we have? Where did we have our lives changing? Can you remember? So here we have the init game.
Isn't it inside Snake head component?
Inside,
where we
that's possible.
Check for bounds.
Die.
There we go. Yeah.
Yeah. This is where we lose a life, and it doesn't check anything.
That's fine. So if after that line we check for lives, which is if get I, which stands for get integer.
Get.
You might need to statically import.
Yeah, probably. Will he? I don't know if
no, it is lowercase, but
it is lowercase.
Probably need to. There we go. It's there.
Yeah, indeed.
That one.
Visual Studio Code recognizes it. Okay, perfect.
Nice. Lives, and if that is 0, then we do something.
Yep.
And that something would be. Well, I suppose a game over screen will do, right?
Mm-hmm.
In which case, get dialog service, show message.
Okay. So message box, I guess. Yep.
Yep. Game over. And then the second argument is the thing to be called when the dialog is dismissed. It's a runnable, so it's just a lambda with no arguments. Do we want to exit the game?
Exit or restart, but restart, yeah. For now, we can
restart too. That's get game controller. So you'll need the parentheses first.
Yeah.
Yep. Get game controller. This thing needs to be renamed because game controller sounds like an Xbox controller or something. Dot Is there a start, restart, something?
Resume.
Interesting. I thought there would be something along the lines of start. Can we try start? Yeah, there we go.
Start new game. Yep, seems to recognize it.
What are we doing after that if statement? Is there anything interesting? Body parts, entity set position. We probably want to do that if statement at the very end.
Or just
return.
Return here. Oh, we exit this. Yeah.
Is there a win condition to any Snake game? Is it when you have no more moves left?
Probably yes.
Which would be incredibly difficult to achieve, I suppose.
It depends. That could be an option of the game, is that you are not allowed to touch yourself, which sounds very that you just have to one big spiral, and then indeed at some point you have no moves left.
Yeah,
but yeah,
I'm just thinking there must be examples where this has been achieved, but I think that would be quite difficult to do.
Yeah,
under normal circumstances. Okay, so all we need to do is die 3 times. Oh, 5 times, because we have 5 lives.
5 times. Nope. Yeah, okay. I found one big issue. If you're coming from IntelliJ, and it is Visual Studio Code doesn't autosave.
Yeah, that would be an issue.
That's really annoying, because if you're an IntelliJ user, you're so used that your code is there in the latest version.
As soon as you update it.
Yeah, they'll always forget to do it here.
I wonder if there's an option in there that says autosave.
Probably. What is this? Yeah, probably there is some kind of autosave. There are a lot of extensions for Visual Studio 2, so probably would find it, but
I actually started with Eclipse, so I was used to Control S all the time, and then I switched to IntelliJ. Now I'm used to not doing anything to do save, which is the problem that I have now with Visual Studio. Whether it's in Unity or with Unreal Engine, I now need to remember to always Control S.
Should look up if there's a plugin, because
yeah, that would be useful. I mean, there's got to be an option. It's not that difficult to implement from their side.
I can go up to
yeah.
Okay, what do we have? Game over, indeed.
Nice.
Yep, and there we are again.
Now,
very nice.
We just need to make sure that we're not somehow reusing any of the existing stuff, because when start new game gets called, everything gets refreshed. So we'd have to. The only thing we have to worry about is any objects that we do not initialize in init game. The factory should be fine because it's initialized there, so that should be fine.
Indeed.
So although for the buttons, I usually create a new one every time for init game.
Yeah. For the joystick, it's not an issue. That's still working.
Okay. Well, that appears to be working fine in terms of both hardware and software.
Yeah. Okay. So I think we've done what I tried to achieve today.
Nice. That's good. Is there going to be a third part to this, or are we going to let the students do the work now?
It's now up to the students. They are starting this week, so they have a very nice starting point. My idea is, so on this hat that is attached to the Raspberry Pi, you have also these extra options to have a speaker. So it would be very fun to have sound effects when the snake touches the border. We can connect any kind of output. So for instance, a LED strip would be a good idea, that we have light effects when we do something good or bad. So that are the initial ideas. So the goal of this university project is to investigate how well gaming can be on the Raspberry Pi. So that's a challenge
so
with the FXGL
that's
library.
a big challenge for us to make sure that this challenge is doable.
Yeah,
because we really want to bring gaming to JavaFX and gaming to Raspberry Pi.
Yeah, because if you look at the price of this, you can build amazing stuff and introduce new people into the Java world. So the goal is that on the Pi4J website, we have a very clear description of how you can build a game. So the Snake game is just an example. It should not be too complicated because we just want to show basic gaming stuff and how to do it with real buttons. And then we will see where we end up. By the way, we're
in which
also
case,
doing.
I'll put all those links into the video description, and we'll let everyone know how to get started on this stuff.
Yeah.
In which case, thanks to the audience for watching this. We apparently won't be making a third part, but we might do a separate video on something different, potentially.
Maybe an idea.
Yeah, we'll see how this goes.
Would the Snake game work with the glue-on tools on a mobile phone?
Stay tuned for the third part, apparently.
Okay.
Thanks, guys, for watching.
We have a subject. Okay, see you then.
See you later.